Now, in this lecture, we'll find out the length of line segment X using three different methods. In the drawing, we have a right triangle. Triangle ABC is a right triangle. Angle ABC equals to 90 degrees. Angle DAC equals to 45 degrees. Side AB of triangle ABC equals to 6 units. Side DC equals to 10 units. And we want to find out the length of side AD, that is actually equals to X. So we will start with the first method. In the first method, we'll do a construction. We will extend line segment AD by a straight line. And from point C, we will go perpendicular to the extended AD. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we'll define the touching point of the perpendicular from point C in the extended AD is point E. So we actually created triangle ACE, that is a right triangle. In the right triangle ACE, the sum of the angles must be equal to 180 degrees. So, which angles we have in the right triangle ACE? Here we have 45 degrees. This angle is equal to 90 degrees according to the construction. And we also have angle ACE, that is a missing angle. This angle plus angle ACE. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we subtract 135 degrees from this equation, and we get that the missing angle, angle ACE, is equal to 180 degrees minus 135 degrees is 45 degrees. So we found out that angle ACE, this angle, equals to 45 degrees. In the next step, we will define line segment DE as Y. Therefore, side AE equals to X plus Y. And here we know that in front of equal angles in the triangle, there are equal sides. So here we have in the right triangle ACE, two equal angles. Both those angles are equal to 45 degrees. So in front of those equal angles, there must be equal sides. That is to say, AE equals to EC. AE equals to EC. But AE equals to x plus y. You can see that A equals to x plus y. From this equation, x plus y equals to AE equals to EC. We will derive that EC is also equals to x plus y. Okay, EC equals to x plus y. And here we have vertex angles, and we know that vertex angles are equal to each other, so we can write down that angle BDA this angle is equal to this angle. This is actually angle EDC. I'll repeat again, angle BDA equals to angle EDC according to the rule that vertex angles are equal to each other. So if we define angle BDA as alpha, then from this equation, alpha equals to angle BDA equals to angle EDC, we will get that angle EDC is also equals to alpha. So in the right triangle, triangle ABD, we know that the sum of the angles is equal to 180 degrees. So if this angle BDA equals to alpha, then this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles in this triangle to 180 degrees. Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. Likewise, in the right triangle DEC, the sum of the angles must be equal to 180 degrees, so this angle equals to alpha, so this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles in this right triangle to 180 degrees. So we actually proved that those two right triangles are similar to each other. We actually proved that the right main triangle, triangle ABD, is similar to the right main triangle, triangle DEC. why those two green right triangles are similar to each other? Because of the fact that both those two right triangles have this angle that are equal to 90 degrees minus alpha. Both those two triangles have this angle that is equal to alpha, and both those two right green triangles have this angle that is equal to 90 degrees. Therefore, those two triangles, they are similar to each other according to angle similarity rule. So I'll write it down. We have triangle ABD and triangle CDE. Those two right green triangles are similar to each other because we have angle BAD. This angle that is equal to angle ECD, this angle, and both angles they are equal to 90 degrees minus alpha. I'll repeat again. In the right triangle ABD, in the right triangle CDE, angle BAD equals to angle ECD, and both angles they are equal to 90 degrees minus alpha. We have those two angles that both of them are equal to alpha. So angle ADB, this angle, is equal to this angle that is actually angle EDC, and both those angles they are equal to alpha. I repeat again, angle ADB equals to angle EDC equals to alpha, and both those two right green triangles have those two angles that are both right angles. So angle ABD equals to angle, this angle equals to angle DEC, and both angles are equal to 90 degrees. I'll repeat again, angle ABD equals to angle DEC, and both angles are equal to 90 degrees. So we actually proved that the right green triangle ABD is similar. This is the sign of similar. The right triangle ABD is similar to the right triangle DEC, according to angle similarity rule. Okay. And from the fact that those two right green triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that AB over EC AB over EC is equal to BD over DE and is equal to AD over DC. I'll repeat again, from the fact that the two right triangles are similar to each other, we conclude that AB over EC equals to BD over DE equals to AD over DC. Okay? AB is equal to 6 units, so we substitute AB by 6. EC equals to Y according to our definition. We substitute EC by Y. And it is equal to BD over here, actually EC equals to X plus Y. So we substitute EC by X plus Y. Here AB equals to 6, EC equals to X plus Y, and it is equal to BD over DE. DE equals to Y according to our definition. Okay, it is equal to BD over DE, that is Y, and it is equal to AD AD equals to X according to what is given us in the question over DC. DC equals to 10 units according to what is given us in the question. So in conclusion, we found out that according to equation number 1, 6 over X plus Y equals to BD over Y equals to X over 10. In the next step, we will find out the size of line segment BD by implementing the Pythagoras theorem on this green right triangle, triangle ABD. In the green right triangle, triangle ABD, according to the Pythagoras theorem, we get that AB squared plus BD squared equals to AD squared. I will repeat again, in the right green triangle, triangle ABD, in the right green triangle, triangle ABD, by PT's Pythagoras theorem, the derivation from Pythagoras theorem, AB squared plus BD squared equals to AD squared. AB equals to 6, so AB squared is 6 squared. 6 squared is 36, plus BD squared is the missing variable, so we will leave it as it is. BD squared equals to AD squared. AD is X, so AD squared is X squared. So we found out that 36 plus BD squared equals to X squared. Here we'll subtract 36 from this equation and we'll get that BD squared equals to X squared minus 36. Here we'll take a root out of this equation and we'll get that BD is equals to the square root of X squared minus 36. So now we can substitute BD in equation number 1 here by square root of x squared minus 36. We'll do it now and we'll get that according to equation number 1, 6 over x plus y equals to BD. Just right now found out that BD equals to the square root of x squared minus 36 over y, and it is equal to x over 10. So from this equation number 1, we will create two equations. The first equation will be those two sides are equal to each other, that is to say six over x plus y is equal to square root of x squared minus 36 over y So this is equation number 1, 6 over x plus y equals to square root of x squared minus 36 over y. Here we'll actually the equation is the equation number 1 states that those two sides they are equal to each other. So equation number 1 according to equation number 1, those two sides they are equal to each other. That is to say 6 over x plus y equals to x over 10. So here we get that according to equation number 1, six over x plus y is equal to x over 10. So according to equation number 1, 6 over x plus y equals to x over 10. Here we'll cross multiply this equation number 1, and we'll get that 6 times 10 is 60, and 60 equals to x times x plus y. We'll open the brackets on this side of equation number 1, and we'll get that according to equation number 1, 60 equals to x times x is x squared plus x times y. Here we subtract from equation number 1 x squared, and we get that according to equation number 1, xy equals to 60 minus x squared In the next step, we create equation number 2. In equation number 2, those two sides are equal to each other. That is to say, according to equation number 2, square root of x squared minus 36 over y is equal to x over 10. So here we cross multiply this equation number 2, and we get that according to equation number 2, ten times square root of x squared minus 36 is equal to x times y. So we have here two expressions for xy. In the next step, we create equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So according to equation number 3, we get that xy according to equation number 1, that is actually 60 minus x squared. It must be equal to xy according to equation number 2, that is actually equals to 10 times square root of x squared minus 36. Here we will square both sides of this equation number 3, and we get that according to equation number 3, $60 minus x squared squared is equal to 10 squared, that is 100, times x squared minus 36, because of the fact that the square cancels the root and we left only with x squared minus 36. So according to equation number 3, we got that 60 minus x squared squared equals to 100 times x squared minus 36. We will open the brackets on both sides of equation number 3, and we will get that according to equation number 3, 60 minus x squared is 60 squared, that is actually 3600, plus x squared is x to the power of 4 minus 2 times 60 times x squared, and it is equal to 100 times x squared, 100 times x squared minus 100 times minus 36 is minus 3600. Here we will add 3600 to this equation number 3, and we get that 3600 plus 3600 is 7200. plus x to the power of 4, and we have minus 2 times 60 is minus 120 x squared, and it is equal to 100 times x squared. Here we'll subtract 100 times x squared from this equation, equation number 3, and we get that according to equation number 3, x to the power of 4 minus 120 minus 100 is minus 220 x squared plus 7200 equals to 0. So here we will substitute minus 220 x squared by minus 180 x squared minus 40 x squared. And we get that according to equation number 3, x to the power of 4 minus 180 x squared minus 40 x squared plus 7200 equals to 0. Here we take x squared as a common factor out of those two expressions, and we get that according to equation number 3, so x squared is a common factor. What is left from x to the power of 4 after we took from it x squared as a common factor? What is left? It is actually x squared. And what is left from minus 180 x squared after we took from it x squared as a common factor? What is left is actually minus 180. And likewise, we took from those two expressions minus 40 is a common factor. So minus 40 is a common factor. So what is left from minus 40x squared after we took from it minus 40 as a common factor? What is left? It is actually x squared. And there, what is left from 7200 after we took from it minus 40 is a common factor? What is left? It is actually minus 180. And it is equal to 0. Now we can take x squared minus 80 as a common factor out of those two expressions, and we get that according to equation number 3, so x squared minus 180 is a common factor. What is left from x squared times x squared minus 180 after we took from it x squared minus 180 is a common factor? What is left? It is actually x squared. And what is left from minus 40 times x squared minus 180 after we took from it x squared minus 180 is a common factor? What is left? It is actually minus 40, and it is equal to 0. So here we will have two solutions that are possible for x. The first solution for x is that x squared, either x squared minus 180 equals to 0. And the second solution from this equation is that either x squared minus 40 equals to 0. So according to the first solution, we get here that x squared equals to 180, And we know that 180 is 36 times 5. So we get here that x squared equals to 36 times 5. Now we take a root out of this equation number 1, and we get that according to equation number 1, x equals to the square root of 36 times 5. And the square root of 36 is 6, so inside the root we have only 5 left. So in conclusion, we found out that according to equation number 1, x equals to 6 times square root of 5, and here 6 times square root of 5 is 13.41 units. That is greater than 10. This is the first solution that we have for x. And the second solution for x is that x squared minus 40 equals to 0, that is to say x squared equals to 40. We take a root out of this equation and we get that x is equal to the square root of 40. 40 is 4 times 10. And the square root of 4 is 2, so in conclusion we found out that according to the second solution, x is equal to 2 times square root of 10, that is actually 6.32, that is less than 10. In conclusion, we have two solutions that are possible for the value of x, that is the value that we are looking for. The first solution is x equals to 6 times square root of 5, that is 13.41, that is greater than 10. And the second solution is that x equals to 2 times square root of 10, that is actually 6.32, that is less than 10 units. So in the next step, I will draw the right triangle, triangle ABD, and the right triangle, triangle ADC, and we will analyze those two triangles in order to find out which solution is true or correct in our specific case. So here we have the right triangle, triangle ABD. So this is the right triangle, triangle ABD. We defined angle BAD is theta. Actually, angle ADC, this angle is defined as an exterior angle to this green right triangle, triangle ABD. So I will write it down. Angle ADC, this angle is an exterior angle of the right green triangle, triangle ABD. Okay? So actually, triangle ABD is this angle, angle ADC, that is an exterior angle, and it has also three interior angles. Angle theta, this angle that is right angle, and this angle that is angle alpha. Those are three interior angles of the right green triangle, triangle ABD. And we have a rule that is related to the size of an exterior angle of a triangle. This will be rule number 1. According to rule number 1, we will get that an exterior angle of a triangle is equal in its size to the sum of the two interior angles that are not adjacent to it. So I write rule number 1 again. According to rule number 1, an exterior angle of a triangle is equal in its size to the sum of the two interior angles that are not adjacent to it. So according to rule number 1, the size of this exterior angle, angle ADC, of the right triangle, triangle ABD, will be equal to the sum of the two interior angles that are not adjacent to it. Angle alpha adjacent to angle ADC, and the two other interior angles of triangle ABD that are not adjacent to it are theta and 90 degrees. So therefore, the sum of those two angles is theta plus 90 degrees or 90 degrees plus theta. So we found out that the size of the interior angle, angle ADC, equals to 90 degrees plus theta And what is the size of this angle? Angle ADC. We know that the sum of the angles in triangle ADC must be equal to 180 degrees. Which angles we have in triangle ADC? We have this angle that is 45 degrees, and we have this angle that is equal to 90 degrees plus theta, and we have the missing angle, angle DCB, DCA. This angle is angle DCA. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we will subtract 135 degrees from this equation, and we will get that theta plus angle DCA is equal to 180 degrees minus 135 degrees is 45 degrees. Here we will subtract theta from this equation, and we will get that the missing angle DCA is equal to 45 degrees minus theta. Okay, this is the missing angle here. Is equal to 45 degrees minus theta. So we can write down that this angle DCA equals to 45 degrees minus theta. So it is very clear from the drawing that this angle DCA is the smallest angle in triangle ADC. Okay? So you can write down that angle DCA that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. I'll repeat again. Angle DCA that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. Okay? And we have also rule number 2. According to rule number 2, the smallest angle in the triangle is always in front of or opposite, in front of the shortest side. I read rule number 2 again. According to rule number 2, the smallest angle in a triangle is always in front of the shortest side. And because of the fact that we found out that this angle is the shortest angle, according to rule number 2, it is located in front of the shortest side. That is to say, AD that is equal to X is the shortest side of triangle ADC. We already know, according to what is given in the question, that DC equals to 10 units. So according to rule number 2, AD that is equal to X is the shortest side of triangle ADC, and because of the fact that AD that is equal to X is the shortest side in triangle ADC, AD that is equal to X must be less than 10 units. Okay, so AD that is equal to X must be less than 10 units. That is to say, X is less than 10 units. According to rule number 2, we found out that X must be less than 10 units. Yeah. So we add two solutions that are possible for X. The first solution is X equals to 6 times square root of 5. That is actually 13.41. It is greater than 10 units. Therefore, this solution is incorrect solution because X must be less than 10 units. So this will cancel this solution because X must be less than 10 units, and here X is greater than 10 units. And we're left only with the solution that X is equal to 2 times square root of 10. That is actually equals to 6.32 units. That is less than 10 units. And that is the solution to the question, that the value of the length of line segment X is equal to either 10 times square root of 10 units, X equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So we finished with the first method. In the next step, I will present to you how to find out the value, the length of line segment X according to the second method. In the second method, we will do another construction. From point D, we will draw a straight line on AC in such a way that the angle that will be created will be equal to 45 degrees. So here In this point, we define the touching point of the straight line from point D and AC is point E. So we draw the straight line DE in such a way that angle AED equals to 45 degrees. We can do it. We can do such a construction that the straight line DE will be equal in such a way that angle AED will be equal to 45 degrees. So in triangle ADE, we know that in front of equal angles in the triangle, there are equal sides. That is to say, according to the rule that I mentioned, AD must be equal to DE. But AD equals to X according to what is given in the question. So from this equation, X equals to AD equals to DE, we will derive that DE is also equals to X. DE is also equals to X. So we can write here that DE equals to X. And we will define angle BAD as theta. So in the right triangle, triangle ABD, angle BAD equals to theta. Therefore, angle ADB must be equal to 90 degrees minus theta in order to complete the sum of the angles in the right triangle, triangle ABD to 180 degrees. Theta plus 90 degrees minus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. So angle ADB must be equal to 90 degrees minus theta. In triangle ADE, we know that the sum of the angles must be equal to 180 degrees. So which angles we have inside triangle ADE? We have one angle that is equal to 45 degrees. This angle is also equal to 45 degrees. Plus the missing angle that is actually angle ADE, this angle. In total, the sum of those three angles must be equal to 180 degrees. Here we will subtract 90 degrees from this equation, and we will get that the missing angle, angle ADE, equals to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that angle ADE is a right angle, therefore triangle ADE is a right triangle. Okay? And we also know here in the drawing we have triangle ABC that is a right triangle. So BC, line segment BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. So BC is a straight line. Line segment BC is a straight line because it is one side of a right triangle. It must be a straight line. Okay, so we know that BC is a straight line. And we have a rule that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC, here at point D, the upper side so if you focus on the upper side of the straight line BC at point D, here, the sum of the angles on the upper side of BC at point D must be equal to 180 degrees according to the rule that I mentioned. So which angles we have on the upper side of the straight line BC at point D? We have here, this angle equals to 90 degrees minus theta. This angle equals to 90 degrees. And the missing angle is angle ADC. Angle EDC. This angle is angle EDC. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So we got here that 90 degrees minus theta plus 90 degrees plus the size of angle EDC must be equal in total to 180 degrees according to the rule that I mentioned. Here 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. And we left only with minus theta plus angle EDC. It must be equal to 0. We will add theta to this equation and we will get that angle EDC, the missing angle EDC equals to theta. We found out that the missing angle equals to theta. So we can write here that the missing angle and EDC equals to theta. In the next step, we will make another construction. From point E, we will draw perpendicular on BC. Okay. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. And we will define the touching point of the perpendicular from point E and BC as F. Actually, we created here triangle DEF that is a right triangle. Okay? This triangle DEF is a right triangle. In this right triangle DEF, this angle equals to theta, therefore the missing angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle EDF to 180 degrees, because theta plus 90 degrees minus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. In the next step, we will prove that those two right green triangles, can go into each other according to angle side angle rule. So we will prove that the right green triangle ABD, is congruent to the right green triangle EDF. Why those two right green triangles can go into each other? First of all, we have two angles that are equal to each other, they are both equal to theta. So we can write down that angle BAD is equal to angle EDF, and both angles are equal to theta. So actually, I'll repeat again. Angle BAD equals to angle DF equals to theta. Those two sides, they are equal to each other, they are both equal to x. So AD, side AD, in triangle ABD is equal to side DE in triangle EDF, and they are both equal to x. I'll repeat again. AD equals to DE equals to x. And those two angles, they are also equal to each other. They are both equal to 90 degrees minus theta. So angle ADB in triangle ABD is equal to angle FED in triangle DEF. And both angles, they are equal to 90 degrees minus theta. I repeat again. Angle ADB in triangle ADB equals to angle FED in triangle EDF, and they are both equal to 90 degrees minus theta. Therefore, we prove that the right triangle, triangle ABD, is congruent. This is the sign of congruent to the right triangle, triangle EDF, according to angle side angle rule. Okay, we actually proved that this side AD, and the two angles that attach to this side, two angles that attach to this side, correspondingly equal to this side DE and the two angles that are attached to this side. Therefore, we prove that those two right angles can go into each other according to angle side angle rule. And from the fact that those two right angles can go into each other, we will conclude that AB is equal to DF. Hence, AB equals to DF. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two green triangles can go into each other. Therefore, the corresponding sides AB and DF will be equal to each other. But it is given us the question that AB equals to 6 units. So we can write down that AB equals to 6 units. And from this equation, 6 equals to AB equals to DF, we will derive that DF is also equals to 6 units. DF is also equals to 6 units. And what is the value of FC? From the drawing, it is very easy to see that FC is equals to DC minus DF. Again, DC minus DF equals to FC. DC minus DF. So FC equals to DC, that is 10 units. It is given as the question. Minus DF, we just right now found out that DF equals to 6. So in conclusion, we found out that FC equals to 10 minus 6, that is 4 units. FC equals to 4 units. So you can write here that FC equals to 4 units. And likewise, from the fact that those two right triangles, green triangles can go into each other, we will conclude that BD equals to EF. BD is equals to EF. Here, BD equals to EF according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, and if we define BD as Y, here we can write down that BD equals to Y according to our definition. From this equation Y equals to BD equals to EF, we will conclude that EF is also equals to Y. EF is also equals to Y. EF equals to Y. In the next step, we will prove that the right triangle, big triangle ABC is similar to the small right triangle, triangle EFC. Okay, we will prove that the right big triangle, triangle ABC is similar to the small right triangle, triangle EFC. So why those two right triangles are similar to each other? First of all, they both have right angle. Right angles, so those two angles are equal to each other, they are both equal to 90 degrees. So angle ABC in triangle ABC is equal to angle EFC in triangle EFC, and both angles are equal to 90 degrees. And repeat again, angle ABC equals to angle EFC equals to 90 degrees. Those two right triangles have also a common angle. This angle is a common angle that belongs to both triangles. So we can write down that angle BCA in triangle ABC is equal to angle FCE in triangle EFC. And the reason is that it is a common angle that belongs to both triangles. So here, angle BCA equals to angle FCE. It is a common angle. And those two angles, they are also equal to each other according to third angle theorem. So we can write down that angle BAC, this angle that is actually theta plus 45 degrees, angle BAC is equal to angle FEC, this angle, and those two angles are equal to each other according to third angle theorem. So what is third angle theorem? Actually, if you have one triangle, if two angles of one triangle congruent to two angles of another triangle, then the first pair of angles must also congruent. Why? Because it is complementary to 180 degrees. Okay? So we actually proved that all the angles of triangle ABC correspondingly congruent to all the angles of triangle EFC. Therefore, we actually proved the triangle ABC is similar, this is the sign of similar, to triangle EFC. According to angle similarity rule. Okay? And from the fact that triangle ABC is similar to triangle EFC, we conclude that AB over BC is equal to EF over FC. I repeat again, from the fact that the right triangle ABC is similar to the right triangle EFC, we conclude that AB over BC equals to EF over FC. AB is equal to 6 units, so we'll substitute AB by 6. BC equals to DC, that is 10 units, plus Y. Again, BC equals to DC, that is 10 units, plus BD, that is Y. In conclusion, BC equals to 10 plus Y. And it is equal to EF. EF is also Y over FC. FC is 4. In conclusion, we found out that according to equation number 1, 6 over 10 plus Y equals to Y over 4. Here we cross multiply equation number 1. And we get that according to equation number 1, 6 times 4 is 24. And it is equal to Y times 10 plus Y. Here we will open the brackets on this side of equation number 1, and we will get that according to equation number 1, 24 is equal to 10Y plus Y squared. We'll subtract 24 from this equation number 1, and we get that according to equation number 1, Y squared plus 10Y minus 24 equals to 0. Okay, so this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general quadratic equation, A, B, and C are the coefficients of the quadratic equation, and x is the variable that we are looking for. We'll find out the value of x according to the following formula. X it is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, y squared plus 10y minus 24 equals to 0, the coefficient a equals to 1, the coefficient b equals to 10, and the coefficient c equals to minus 24, and the variable that we're looking for is y, so x it is equal to y. We put the data inside the formula for x in order to find out the value of the values of y. So x equals to y, so we write down that y it is equal to minus b, b equals to 10, so minus b is minus 10, plus minus square root of b squared. B is 10, so b squared is 10 squared, 10 squared is 100, minus 4 times a is 1, times c is minus 24. Over 2a, a is 1, so 2 times 1 is 2. So here we get that y equals to minus 10 plus minus 4 times minus 24 is plus 96, and 96 plus 100 is 196, 196 over 2. So here we found out actually that y is equal to minus 10 plus minus the square root of 196 is 14 over 2. So here we will have two solutions that are possible for y. The first solution, we define it as y1, will be equal to minus 10 minus 14 over 2. Minus 10 minus 14 is minus 24, and minus 24 over 2 is minus 12. So we found out that the first solution is y equals to minus 12. But because of the fact that y here equals to bd, y is a length. It is the length of side BD. So y is a length, y is a length, therefore it must be a positive number, and y1 equals to minus 12 is a negative number, therefore we will cancel this solution, it is not correct, and we're left only with the second solution, that y equals to minus 10 plus 14 over 2. Minus 10 plus 14 is 4, and 4 over 2 is 2. So we found out that y2 equals to 2. So we can write here that y equals to 2. Now I will copy the right triangle ABD, and we will implement the Pythagoras theorem on this right triangle in order to find out the value of x. Okay? According to the Pythagoras theorem, in the right triangle ABD, AB squared plus BD squared equals to AD squared by PT's Pythagoras theorem. AB is 6, so AB squared is 6 squared, that is 36, plus BD is 2, so BD squared is 2 squared, that is 4, and it is equal to AD squared. AD is x, so AD squared is x squared. 36 plus 4 is 40, so we found out that x squared equals to 40. We take a root of this equation and we get that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that x equals to 2 times square root of 10 units. Or in terms of numbers, it is equal to 6.32 units. That is the answer to the question. In the next step, I will present to you how to find out the length of line segment X according to the third method. In the third method, we'll define angle BAD as theta, and we will define side BD of the right triangle ABD as y. So in the right triangle ABD, we know that tangent theta is equal to BD over AB BD is equal to y according to our definition, and AB equals to 6. So in conclusion, we found out that tangent theta in the right triangle ABD is equal to y over 6. In the right triangle ABC, here tangent theta plus 45 degrees equals to BC over AB. Here BC equals to y plus 10 and AB equals to 6. So in conclusion, we found out that in the right triangle ABC, tangent theta plus 45 degrees is equal to y plus 10 over 6. Okay? And we have trigonometric identity tangent 45 degrees plus theta is equal to 1 plus tangent theta over 1 minus tangent theta. We use this trigonometric identity and we will substitute tangent theta plus 45 degrees in this equation number 1 by 1 plus tangent theta over 1 minus tangent theta. And we get that according to equation number 1, tangent theta plus 45 degrees equals to 1 plus tangent theta over 1 minus tangent theta. And according to equation number 1, it is equal to y plus 10 over 6. But we have already found out that tangent theta equals to y over 6, so we can substitute tangent theta in equation number 1 by y over 6, and we do it now, and we get that 1 plus tangent theta is y over 6 over 1 minus tangent theta is also y over 6, and it is equal to y plus 10 over 6. Here we multiply 1 by 6 and then we divide it also by 6 in order to have a common factor with y over 6 and with minus y over 6. And we get that according to equation number 1, 6 plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. So here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled. And what is left from equation number 1 after we cancelled 6? What is left? It is actually 6 plus y over 6 minus y equals to y plus 10 over 6. Okay? So here we'll cross multiply equation number 1 and we will get that according to equation number 1, 6 times 6 plus y equals to 6 minus y times y plus 10. We will open the brackets on both sides of equation number 1 and we will get that according to equation number 1, 6 times 6 is 36 plus 6y, and it is equal to 6y, and 6 times 10 is 60, minus y times y is minus y squared, and minus y times 10 is minus 10y. Here we have 6y in both sides of the equation. Number 1, so 6y will get cancelled. And what is left from equation number 1 after we cancelled 6y? What is left is actually here. In this side we have 36. And on the other side we have 60 minus y squared minus 10y. We will add y squared and also 10y to this equation, equation number 1. And we get that according to equation number 1, y squared plus 10y plus 36 equals to 60. We'll subtract 60 from this equation, equation number 1, and we get that y squared plus 10y, 36 minus 60 is minus 24, is equal to 0. So here we have exactly the same quadratic equation that we solved in the second method. So we know that the solution to this quadratic equation, one solution is y that is equal to minus 12, but because of the fact that y is a length, it cannot be equal to a negative number, so this solution will get cancelled, and we're left only with the solution that y equals to 2. Then I drew the right triangle ABD, and in the right triangle ABD, we have AB equals to 6, BD equals to y that is 2, and AD is the missing variable x. So we implemented the Pythagoras theorem on the right triangle ABD. According to the Pythagoras theorem, on the right triangle ABD, by Pythagoras theorem, we'll get that AB squared plus BD squared equals to AD squared. AB is 6, so AB squared is 36, plus BD is 2, so BD squared is 2 squared, that is 4, and it is equal to AD squared, that is AD is x, so AD squared is x squared. 36 plus 4 is 40. 40 equals to x squared. We'll take a root out of this equation, and we get that x equals to the square root of 40. 40 is 4 times 10. The square root of 4 is 2, so in conclusion, we found out that x, the line segment that we are looking for, the length of line segment x is either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, in the next step, I will summarize the lecture. We start with the first method. So here we have the right triangle ABC. We know that AB equals to 6 units, DC equals to 10 units, angle DAC equals to 45 degrees, angle ABC equals to 90 degrees, and we want to find out the value of line segment AD that is actually equals to x. So here we made a construction. We extended the line segment AD by a straight line, and then from point C we drew perpendicular to the extended AD. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And we define the touching point of the perpendicular from point C and the extended AD is point E. So we created here triangle AEC, that is a right triangle, and we know that the sum of the angles in a triangle is equal to 180 degrees. So in triangle AEC, this new triangle that we created, we have one angle that is 45 degrees. This angle is equal to 90 degrees according to our construction, and plus the missing angle that is angle ACE. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 135 degrees from this equation, and we found out that the missing angle ACE equals to 180 degrees minus 135 degrees, it is 45 degrees. So this angle ACE equals to 45 degrees. Then we defined line segment DE is y. Therefore, AE equals to x plus y. In the right triangle AEC, we have two angles that are equal to each other, and we know that inside of equal angles in the triangle, there are equal sides. That is to say, in front of equal angles in the triangle, there are equal sides. Therefore, in front of those two equal angles, there must be an equal side. That is to say, AE must be equal to EC. AE must be equal to EC, but AE equals to x plus y. So from this equation, x plus y equals to AE equals to EC, we derive that EC is also equals to x plus y. Okay? Then, here we have two vertex angles. Those two vertex angles, they are equal to each other. That is to say, angle BDA equals to angle EDC. According to the rule that vertex angles are equal to each other. So if we define angle BDA as alpha, then angle EDC will be equal also to alpha, because they are equal to each other. Then we proved, we proved that those two right green triangles are similar to each other. Here, first of all, because of the fact that the right triangle ABD, in the right triangle we have this angle that is alpha, then this angle must be equal to 90 degrees minus alpha in order to complete the sum of the angles. In this right green triangle, 280 degrees, this angle must be equal to 90 degrees minus alpha for the same reason. In this right triangle, this angle must be also equal to 90 degrees minus alpha. So in these right green triangles, we have those two angles that are equal to each other. They are both equal to 90 degrees minus alpha. Those two angles that they are also equal to each other, they are both equal to alpha. And those two angles that are also equal to each other, they are both right angles, they are equal to 90 degrees. So we, in conclusion, found out that the right green triangle ABD is similar to the right triangle EDC according to angle similarity rule. And from the fact that those two right green triangles are similar to each other, we will conclude that AB over EC equals to BD over DE equals to AD over DC. AB equals to 6, EC equals to x plus y, BD equals to BD, and DE equals to y according to our definition. AD equals to x and DC equals to 10. And in order to find out the value of BD, we implemented the Pythagoras theorem on the right green triangle ABD. According to the Pythagoras theorem, in this right green triangle, AB squared plus BD squared equals to AD squared. AB squared in the right triangle ABD, AB squared plus BD squared equals to AD squared. AB is 6, so AB squared is 6 squared is 36, plus BD squared equals to AD squared. AD is x, so AD squared is x squared. We subtracted 36 from this equation and we got that BD squared equals to x squared minus 36. We took a root out of this equation and we got that BD equals to the square root of x squared minus 36. Now we can substitute BD in equation number 1 by square root of x squared minus 36. We did it and we got that according to equation number 1, 6 over x plus y equals to square root of x squared minus 36 over y, that is equal to x over 10. Then we created from this long equation two equations. The first equation is that those two sides are equal to each other. That is to say, 6 over x plus y equals to x over 10. We cross multiply equation number 1. And we got that 6 times 10 is 16. It is equal to x times x plus y. We open the brackets on this side of equation number 1. And we got that x times x is x squared. Plus x times y. So in conclusion, according to equation number 1, we found out that 60 equals to x squared plus xy. We subtracted x squared from this equation number 1, and found out that xy equals to 60 minus x squared. This is equation number 1. Then from this equation, we created the second equation. Those two expressions, they are equal to each other. That is to say, square root of x squared minus 36 over y equals to x over 10. We cross multiply the equation number 2, and we got that according to equation number 2, 10 times square root of x squared minus 36 equals to x times y. Then, so we have two different expressions for x, y. Then we created equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So according to equation number 3, xy according to equation number 1, that is 60 minus x squared, must be equal to xy according to equation number 2, that is actually equal to 10 times square root of x squared minus 36. Here we squared both sides of equation number 3. We got that 60 minus x squared equals to 10 squared, that is 100. And here the square cancels the root, and we left only with x squared minus 36. We open the brackets on both sides of the equation number 3, and we got that 60 minus x squared equals to 60 squared, that is 3600, plus x squared is x to the power of 4, minus 2 times 60 times x squared. And it is equal to 100 times x squared minus 100 times minus 36 is minus 3600. Then we added 3600 to this equation number 3, and we got that 3600 plus 3600 is 7200, plus x to the power of 4, minus 2 times 60 is minus 120 x squared, and it is equal to 100x squared. We subtracted 100x squared from this equation number 3. So minus 200x squared minus 100x squared is minus 220x squared. So in conclusion, we got that according to equation number 3, x to the power of 4 minus 220x squared plus 7200 equals to 0. Then we substituted minus 220x squared by minus 100x squared minus 40x squared. And we got x squared minus 180x squared minus 40x squared plus 7200 equals to 0. Here, from those two expressions, from this expression, we took x squared as a common factor. So inside the brackets, we will have x squared minus 180. And from those two expressions, we took minus 40 as a common factor. And inside the brackets, we will have x squared minus 180. Then we took x squared minus 180 as a common factor from those two expressions. And inside the brackets, we will have x squared minus 140. So we will have here two solutions that are possible for x. The first solution is x squared minus 180 equals to 0, and the second solution is x squared minus 40 equals to 0. According to the first solution, x squared equals to 180. So 180 is 36 times 5. We took out of this equation number 1, and we got that x equals to the square root of 36 times 5. The square root of 36 is 6. So in conclusion, we got that according to equation number 1, x equals to 6 times square root of 5, and 6 times square root of 5 is 13.41, that is greater than 10 units. And according to the second solution, x squared minus 40 equals to 0, that is to say x squared equals to 40. We took out of this equation number 2, and we got that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we got that according to the second solution, x equals to 2 times square root of 10 units, that is 6.32 units, that is less than 10. So then I copied the right triangle ABD, and the right triangle ADC in this new page. In this drawing, you can see that angle ADC is the external angle on the right triangle ABD. Okay, and we have rule number 1 about the size of an external angle in the triangle. According to rule number 1, an external angle of a triangle is equal in its size to the sum of the two internal angles that are not adjacent to it. So here we have the external angle, angle ADC. Angle alpha attached to it is adjacent to it, and the two other angles, internal angles that are not adjacent to it are theta and 90 degrees. So according to rule number 1, the size of angle ADC, external angle ADC, will be equal to the sum of the two angles that are not adjacent to it. That is to say, it will be equal to 90 degrees plus theta. And we know that the sum of the angles in any triangle is equal to 180 degrees, and especially it's true in triangle ADC, the sum of its angles must be equal to 180 degrees. So which angles we have in triangle ADC? We have 45 degrees, and we have this angle that is 90 degrees plus theta, and we have this missing angle, angle ACD. In total, the sum of those three angles must be equal to 180 degrees. We subtracted 135 degrees from this equation, and we got that angle theta plus angle DCA equals to 180 degrees minus 135 degrees is 45 degrees. So in conclusion, we got the theta plus angle DCA equals to 45 degrees. We subtract the theta from this equation, and we got that the missing angle, angle DCA equals to 45 degrees minus theta. And because of the fact that angle ACD equals to 45 degrees minus theta, from the drawing you can see that this angle that is equal to 45 degrees minus theta is the smallest angle in triangle ADC. Okay? Yeah. And we have also rule number 2 that states that the smallest angle in a triangle is always in front of the shortest side. Therefore, we know that angle ADC, we know that this angle, angle ACD, that is equal to 45 degrees minus theta, is the smallest angle. And according to rule number 2, the smallest angle is always in front of the shortest side. That is to say, AD that is equal to X is the shortest side in triangle ADC. And DC equals to 10 units. Therefore, AD that is equal to X must be less than 10 units. AD that is equal to X must be less than 10 units, or X must be less than 10 units according to rule number 2. So we have two solutions that are possible for X. The first solution for X is X equals to 6 times square root of 5. That is actually 13.41 units. That is greater than 10. So this solution is incorrect solution because X must be less than 10 units. Therefore we cancel this solution and we left only with the solution that X equals to 2 times square root of 10 units, that is actually 6.32 units, that is less than 10 units. So in conclusion, the solution to the question is that X equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method. Then I presented to you how to solve how to find out the value of line segment X according to the second method. In the second method, we made another construction. Here, from point D, we draw a straight line to AC in such a way that angle AEC will be equal to 45 degrees. It is possible to do it. Okay, and here in triangle ADE we have two equal angles, and we know that in front of equal angles in the triangle there are equal sides. That is to say, AD must be equal to DE, but AD equals to X. So from this equation, X equals to AD equals to DE, we derive that DE is also equal to X. And in the right triangle, triangle ADE, we know that the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle ADE? We have 45 degrees plus 45 degrees, and we have the missing angle, that is angle ADE. In total, the sum of those three angles must be equal to 180 degrees. 45 degrees plus 45 degrees is 90 degrees, so we subtracted 90 degrees from this equation, and we got that the missing angle, angle ADE, equals to 90 degrees. This angle, the missing angle, angle ADE, equals to 90 degrees. Okay? Then, we defined angle BAD as theta, and in the right triangle, triangle ABD, if angle BAD equals to theta, then angle BDA must be equal to 90 degrees minus theta in order to complete the sum of the angles to 180 degrees. So we have this angle that is equal to 90 degrees minus theta, we have this angle that is equal to 90 degrees, and we have the missing angle, angle EDF. But we know that in triangle ABC, side BC is one side of triangle ABC, therefore it is absolutely a straight line. If it's a side of a triangle, it must be a straight line. So BC is a straight line, and we have the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then according to the rule that I mentioned, the sum of the angles on the upper side of BC at point D must be equal to 180 degrees. So on the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees. So which angles we have here? On the upper side of BC at point D, we have 90 degrees plus theta, we have 90 degrees, and we have the missing angle, angle EDF. In total, they must be equal to 180 degrees. 90 degrees minus theta plus 90 degrees plus the size of angle EDC. In total, they must be equal to 180 degrees. 90 degrees plus 90 degrees is 180 degrees, so we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled, and we left only with minus theta plus angle EDC, that is equal to 0. We added theta to this equation, and we got that the missing angle, angle ADC, equals to theta. So this angle equals to theta. So, and then we make another construction, we made another construction from point E, we draw perpendicular on BC. So this angle equals to 90 degrees, and this angle equals to 90 degrees, and we define the touching point of the perpendicular from point E and BC as point F. So we have here right triangle, triangle EDF. In this right triangle, if this angle equals to theta, this angle must be equal to 90 degrees minus theta. Okay? So, then we proved that those two right triangles can go into each other. Right, they can go into each other. First of all, we have those two angles that are equal to each other, they are both equal to theta. We have angle, side AD that is equal to side DE, both they are equal to x. And we have those two angles, they are equal to each other, they are both equal to 90 degrees minus theta. So we found out that triangle ABD can go into triangle EDF according to angle side angle rule. And from the fact that those two triangles can go into each other, we conclude that AB equals to DF. AB equals to DF according to the rule that corresponding sides and congruent triangles are equal to each other. But AB equals to 6 units. It is given in the question. So we have 6 equals to AB equals to DF. From this equation we derive that DF is also equals to 6. DF equals to 6. So if DF equals to 6, then what is the value of FC? FC will be equal to DC minus DF. Here FC equals to DC minus DF. So FC equals to DC, that is 10 units, minus DF, that is 6. That is to say FC equals to 10 minus 6, that is 4. So we found out FC equals to 4. Likewise, because of the fact that those two green right triangles can go into each other, BD must be equal to EF. BD must be equal to EF, and we define BD as y. So from this equation, y equals to BD equals to EF, we derive that EF is also equals to y. Then we proved that triangle ABC is similar to the right triangle, triangle EFC. Right, those two right triangles are similar to each other. First of all, they both have right angles, and then they have this angle is a common angle, it belongs to both triangles. And the third angle must be, the third pair of angles must be also equal according to the third angle theorem. Therefore, we actually proved that all the angles in the right triangle ABC can go into all the angles in triangle EFC, and therefore we can derive from it that AB over BF equals to EF over FC. AB over BC equals to EF over FC. AB over BC equals to EF over FC. AB is 6, BC is 10 plus Y, EF is Y, and FC is 4. So we solved this equation and we got to the quadratic equation y squared plus 10y minus 24 equals to 0. This is exactly the same quadratic equation that we got. We solved this quadratic equation, and the solution to this quadratic equation is either y is equals to either minus 12 or y equals to 2. But because of the fact that y is a length, it must be a positive number. It cannot be equal to minus 12. So the only solution that is left is that y equals to 2. So we have here in this right triangle, triangle ABD, BD equals to 2, AB equals to 6, and AD equals to x. So according to the Pythagoras theorem, AB squared plus BD squared equals to AD squared. AB is 6, so AB squared is 6 squared, is 36, plus BD squared. BD is 2, so BD squared is 2 squared, that is 4. So, and AD equals to x, so AD squared is x squared. So in conclusion, we found out that x squared equals to 36 plus 4. That is to say, x squared equals to 40. We took out of this equation and we got that x equals to the square root of 40. The square root of 40 is either equals to 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. We finished with the second method. Then I presented to you how to find out the length of line segment X according to the third method. In the third method, we defined angle BAD as theta and side BD as y. In the right triangle, triangle ABD, we know that tangent theta equals to BD over AB, BD equals to y, AB equals to 6. So in conclusion, we found out that in the right triangle, triangle ABD, tangent theta equals to y over 6. Then in the right triangle, triangle ABC, we know that tangent theta plus 45 degrees equals to BC over AB. BC equals to y plus 10, AB equals to 6. So in conclusion, we found out that tangent theta in the right triangle, triangle ABC equals to y plus 10 over 6. Then we have trigonometric identity for tangent theta plus 45 degrees. According to the trigonometric identity, tangent 45 degrees plus theta equals to 1 plus tangent theta over 1 minus tangent theta. So we can substitute tangent 45 degrees plus theta in equation number 1 by this expression. We did it and we got that 1 plus tangent theta over 1 minus tangent theta equals to, according to equation number 1, y plus 10 over 6. But we have already found out that tangent theta equals to y over 6. So we can substitute tangent theta in equation number 1 by y over 6. We did it and we got that 1 plus tangent theta is y over 6 over 1 minus tangent theta, and tangent theta is y over 6 equals to y over 10 over 6. Here we multiplied 1 by 6 and then we divided it by 6 in order to have a common factor with y over 6 and with minus y over 6, and we got that 6 plus y over 6 over 6 minus y over 6 equals to y plus 10 over 6. Here we have 6 in the numerator and in the denominator, so 6 will get cancelled, and we're left only with 6 plus y over 6 minus y equals to y plus 10 over 6. We cross-multiplied equation number 1, and we got that 6 times 6 plus y equals to 6 minus y times y plus 10. We open the brackets on both sides of equation number 1, and we got that 6 times 6 is 36, and 6 times y is 6y, and it is equal to 6y plus 60 minus 4y. Here it is minus y squared minus 10y. Here we have 6y on both sides of the equation, so 6y will get cancelled, and we left only with 36, that is equal to 60 minus y squared minus 10y. We added y squared and 10y to this equation number 1, and we got that y squared plus 10y plus 36 equals to 60. We subtracted 60 from this equation number 1, and we got that y squared plus 10y minus 24 equals to 0. So this equation, the quadratic equation, is exactly the same equation, the same quadratic equation that we got in the second method. We have already solved this quadratic equation and found out that we will have here two solutions that are possible. The first solution is y equals to minus 12, and the second solution is y equals to 2. But because of the fact that y is a length, it must be a positive number, so this solution, minus 12, this is negative solution, is incorrect solution. We cancel this solution, and we left only with the solution that y equals to 2. So here, y BD that is equal to y equals to 2 units, AB equals to 6 units, and AD equals to x. So we implemented the Pythagoras theorem on this right triangle, triangle ABD. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. That is to say, AB square plus BD square must be equal to AD square. AB is 6, so AB square is 6 squared, that is 36. BD is 2, BD square is 2 squared, that is 4. And it is equal to AD squared, that is x squared. 36 plus 4 is 40. So x squared equals to 40. We took out of this equation, and we got that x equals to the square root of 40. The square root of 40 is either equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So the answer to the question is that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, thank you very much.